Saxon Algebra 2, lesson 72, students. I plugged in my phone and it disconnected the video. So I did the last problem and a half and you weren't watching. Isn't that sad? This is where we were, as you probably remember better than I do. We were doing example 71.1. We were using our new friend, the quadratic formula, which we had derived earlier. I talked to you about using buckets for the win. I had plugged in the A, B, and C values that we got right there. And I believe I had just simplified what was inside of the radical. And I was in the process of getting ready to copy that over when drama happened. So this is example 71.1 continued. And we're at the point of summary where x equals I'll rewrite some of it. Minus 2 plus or minus the square root of, and we'd gotten this down to minus 56, and this was over 2 times 3. Okay, that's where we were. Let's summarize or simplify this again. X equals positive 2 plus or minus. Now let's see what's going to happen here. We know for sure it's going to be square root of 56i because we don't want a minus sign inside of an even numbered root. That's drama. So we'll change it to this. Now, can we simplify this to take some pigs out? 56 breaks down into 8 times 7. 7's prime. 8 I know will go down into a threesome, a trio of 2's, you might say. So let's take out a pair of 2's. That'll give us a single 2 on the outside. This is left inside, so we have square root of 14, and then we have the I to contend with. And on the bottom, 2 times 3 is 6. All right, this is looking good. What I notice is even number, even number, even number. So we'll be able to do a bit of canceling. The first thing we have to do is factor the 2 out of the top. We can't just cancel it because we're adding. So I'll write it as 2, and I'm factoring the numerator. So I'm going to need a placeholder there because I'm factoring the whole thing out. Plus or minus square root of 14i. I don't need a placeholder here because the 14i is still there. I factored out that 2 and that 2. Okay, then this is all over 6. Now I can cancel 3 and 1. So I get x equals, now here I have to be careful. Let me just write it the wrong way first. Plus or minus square root of 14i over 3. That's the wrong way because with a complex number, we always want to use this presentation, and that means they have to be separate. So the proper way to write this is 1 over 3 plus or minus square root of 14i over 3. That's the right answer. I don't even have to check my book because look, here's what I did while you were not able to be with me. All right, so that's the right answer. Yay. Now, there's one more problem in this lesson. Example 71.2. And it looks like this. Scream when you see what's wrong. Yes, I hear you screaming because here's the problem. This is the standard form of a quadratic equation, and this is how we need it arranged before we can start quadratic formulaing. This guy is in violation. These guys are on the dark side. They need to come over to, I don't know what, to be freedom fighters. So let's rearrange. We'll change the sign of these because we know that's what happens when we swim them across the equal sign. All right, now we're ready to set up our A and our B and our C. Beautiful. A, look, there's nothing there, so that's just a 1. B is minus 3. C is negative 28. Okay, fabulous. Let's put our formula down. Please memorize this. Do whatever you have to do. I don't know if this was in the video before it cut out or after, but I was like, to tattoo it on your brother's head with a Sharpie, use up all of your mom's shopping notepad, writing it over and over and over. Run the shower so that the mirror steams up and write it with your finger on the mirror till you run out of room. I don't care. Do something creative, do something fun. Don't tell your mom that it was my idea to write it on your brother's forehead. But practice this because it's going to be your review problem this week. This week. I know I'm being really mean. So I want you to know this little pup by heart. Okay, let's put in some parentheses so we won't make any mistakes. Yay! Now, there's two ways to fill these in. What I did last time was I said, okay, let's put our A's in where they go. Then let's put our B's in where they go. And then let's put our C in. That just goes in one place. That's perfectly fine. You can work through your list. Other people like to take the variables in the order that they show up in the equation or the formula. So I would say, okay, let's do my B first. -3 here, -3 here. Then my A goes here. Then my C goes here. And then I need another A down there. Either way is perfectly fine. Experiment, find the way you like better. Just make sure you have a thorough process so you don't screw it up. Okay, -3 quantity squared is +9. These two become a plus. 4 times 28, let's figure out what that is. 2, it's 112. Okay, and I'm gonna add those together and I get 121. Now, as I write that number down, little alarm bells go off in my head because I recognize that as a perfect square. That is 11 squared. I'm not gonna do anything with that yet because I have a big mess here, so I wanna simplify before I go on, but I'm gonna keep that in mind. Okay, x equals +3 plus or minus the square root of 121 all over 2. Whoa. X equals 3 plus or minus 11 over 2. And I realize I've got nice, cute integers here. I don't have any radicals. I don't have any imaginary numbers. This one's really straightforward. So I can break this plus and minus sign down to say either x equals 3 plus 11 over 2 or x equals 3 minus 11 over 2. This is going to come out to have cute answers, right? So 3 plus 11 is 14. 14 divided by 2 equals 7. 3 minus 11 is -8. -8 divided by 2 is -4. So I get integers for my answers, which is cool, and that's right, by the way. But what that makes me think is, wait a minute, if my answers are integers, then I should have been able to solve this original equation in its proper form. Not this drunken mess that John left us, but once I got it straightened out, I could have been able to solve that by inspection. So let's just try that. So I'm gonna have an alternative route. It's gonna come down here. X squared minus 3x minus 28. Okay, what multiplies to minus 28 and adds to minus 3? My brain goes quickly because these numbers are familiar. -7 and 4 are the numbers. And I think, but wait a minute, the signs are reversed. No, hold on. We take these values, we rewrite them as a binomial, right? X minus 7, x plus 4, equals 0, which means either x minus 7 equals 0 or x plus 4 equals 0. And now we swim that across and we get x equals 7 and -4, which is exactly the same. So what we learned, well, our takeaway from this last problem, this is the last problem for this lesson, is this. No matter what kind of answer a quadratic equation has, we can always use the quadratic formula to factor it. It will always work. And for that matter, completing the square will too, because they're basically two ways of doing the same thing. So completing the square and quadratic formula work for anything. If the numbers are simple enough, and we can't always tell by looking, we have to do our inspection thing with our minus, our subtracting, our multiplying and adding. Sometimes we can take the short version, because look how much shorter that is, right? So if you just glance at that original equation and go, wait, I think I can do this by inspection, by all means, go ahead and try. But it will never be wrong to solve by the quadratic formula. That will never be a mistake. You'll never get to the end and go, oh, this wasn't the right kind of quadratic equation for the formula. No, it always works. And P.S., for a while, John is going to tell you, use the quadratic formula to solve. So you have to do what he says. You can't do it by inspection if he tells you to do it the long way. But this is a really nice illustration that the formula works for everybody, and you can never go wrong with the quadratic formula. Isn't that a comforting thought? Oh, I hope you just write it on a piece of paper and tuck it under your pillow at night. It will come to you in your dreams, and it will chase away the boogeyman. You can never go wrong with this sweet little creation. Okay, that is the end of Lesson 71. Thank you. Goodbye.